Ever wonder how doctors get those super detailed images of your body without cutting you open? That's MRI right. But here's the catch. MRI scans take ages because they need to collect a ton of data. To speed things up, machines often skip some of that data, like leaving puzzle pieces out. The challenge? Reconstructing the full picture from the scraps. Traditional methods use local clues, like nearby pixels, to guess the missing bits. But here's the problem. K-space, the data realm MRI works in, isn't just a local game. It's got global patterns, like a big interconnected web. Missing pieces can mess up the whole picture if you only look at the neighbors. Enter transformers. You've heard of them in AI. They're like the ultimate puzzle solvers, spotting long-range connections. But here's the twist. Most transformers are black boxes. You feed them data and they spit out answers, but you can't peek inside to see how they work. That's a problem when you're dealing with medical imaging. Trust matters. So what's the fix? Meet GPI-WT, a white box transformer. Think of it as a transparent puzzle solver. It's designed specifically for MRI, using a clever math trick called globally predictable interpolation. Instead of guessing randomly, it learns the big picture patterns in K-space, like a detective following clues across the entire data set. Here's how it works. Imagine K-space as a giant spreadsheet. GPI-WT doesn't just look at the cells next to each other. It spots hidden relationships across the whole grid. It uses something called a low-rank model to simplify the data, making it easier to spot those global patterns. And because it's a white box, we can actually see how it makes decisions. No magic involved. The proof. This method outperforms the best existing techniques. In tests, it reconstructed MRI images with more detail and fewer errors, even when huge chunks of data were missing. Plus, doctors can trust it because they understand why it works. So next time you hear about AI in healthcare, remember, some models aren't just smart, they're transparent. And that's a game changer for medicine. Thanks for watching. If you want more deep dives into tech and science, hit that subscribe button. Until next time, stay curious. Hey everyone, welcome back. Today we're diving into a cutting-edge technique, revolutionizing medical imaging. GPI-WT, a white box transformer that's reshaping how MRI scans are reconstructed. Ever wondered how doctors get those detailed body images? It starts with K-space, a mathematical representation of raw MRI data. But here's the problem. Capturing that data takes time. Traditional methods often skip pieces, leading to blurry images. So how do scientists fix this? Let's break it down. GPI-WT isn't just another tweak, it's a paradigm shift. Unlike black box models that act like magic boxes, GPI-WT is transparent, letting us see how it makes decisions. That's critical for medical applications, where trust and accuracy are non-negotiable. The heart of GPI-WT lies in a clever mathematical formula. Think of it as a balance sheet. One side ensures the reconstructed image matches the raw data, like double-checking your math, while the other enforces natural patterns. Two key components here are local predictability and global structure. Local predictability uses a technique called SPIRiT to estimate nearby data points, while global structure leverages a transformer's ability to spot long-range patterns, like recognizing a face in a crowd. But here's where it gets really smart. Traditional methods struggle with long-range dependencies in K-space, where distant data points are actually connected. To solve this, the team developed a linear window strategy. Imagine slicing the data into narrow strips instead of square blocks. This lets the model see across the entire image, not just small chunks, while keeping computations efficient. The results? Let's talk numbers. When tested on knee MRI data, GPI-WT outperforms state-of-the-art methods like SPIRiT, KNet, and even other transformers. Metrics like normalized mean square error, NMSE, and structural similarity index, SSIM, showed significant improvements, meaning fewer artifacts and sharper images. And when they tested different components, like the linear windows versus square ones, the model's performance dropped without them, proving their importance. What does this mean for the real world? Faster scans, clearer images, and potentially better diagnoses. By combining the best of deep learning with physics-based principles, GPI-WT is a game changer. It's not just about speed, it's about making medical imaging more reliable and accessible. Ever wonder how doctors can create clear images of your body in just minutes? Magnetic resonance imaging, or MRI, relies on a tricky process called K-space interpolation to speed things up. Think of K-space as a mathematical puzzle. Each piece represents data about your body's tissues. But when scans are rushed, some pieces go missing. That's where clever algorithms step in, filling in the gaps to rebuild sharp, detailed images. Today, we're diving into a groundbreaking approach that's changing the game. Researchers have developed a method called GPI-WT, short for globally predictable K-space interpolation with a white box transformer. This isn't just another tweak to old techniques. It's a whole new way of thinking about MRI reconstruction. So how does it work? Let's break it down. Traditional methods often rely on guesswork or rigid rules. But GPI-WT uses something called learnable parameters. Think of them as adjustable knobs that the algorithm fine-tunes during training. These parameters help the model understand patterns in the data, like a chef mastering a recipe through trial and error. Here's the cool part. the team uncovered a hidden trick by unfolding a mathematical process called subgradient-based optimization into a layered network. This created the first white box transformer tailored for MRI. Transformers, you might know from AI chatbots, are great at focusing on the most important details. In this case, they act like a spotlight, highlighting critical areas of the K-space puzzle to reconstruct images faster and more accurately. The results? GPI-WT outperforms existing methods in both speed and clarity. Imagine a puzzle where every piece fits perfectly, even when parts are missing. The researchers tested it under challenging conditions, like when only a quarter of the data is captured, and it still delivered stunning results. Plus, because the model is interpretable, scientists can actually see how it makes decisions, unlike black box AI that works like a mysterious black hole. But this is just the beginning. Right now, GPI-WT focuses on K-space itself. The next step: extending this transparent, attention-driven approach to the image domain, meaning the final pictures we see. If successful, this could make MRI scans not only faster, but also more reliable for diagnosing everything from tumors to brain injuries. So what's the takeaway? By blending mathematical rigor with cutting-edge AI, researchers are paving the way for smarter, clearer medical imaging. And who knows? The next time you step into an MRI machine, you might be benefiting from a little bit of transformer magic.